Hi guys, welcome back my channel, The Learning Destinations. I'm your host Avinash, and today once again I'm back with a very interesting topic, and which is again from the machine learning background. So in this sessions I'm going to talk about the CNN, which is also well known by Convolutional Neural Network. It is a deep learning model for processing structured grid data, and it is often used for image recognition, which are also having a better accuracy than dense layer. So now let's understand convolutional neural network. Alright guys, so now I'm going to explain you that how the model learns about the image classification and what are the steps involved in this entire process. Now let's understand this entire procedure. So we have an image, and this is the horse image which we are taking as an input value. After that we are applying the convolutional layer, and basically at this step we apply con 2D layer, and after applying this con 2D layer we are converting this normal image into the convoluted image. So at this point, if you don't know about the convoluted image, don't worry guys, because under the same session I'm going to explain you what is convoluted image. And then we apply the max pool. Basically by applying max pool we are reducing the size of original image, and then we apply the flatten layer. So under this sessions we are converting this 2D image into the vector, and then we further activate the ReLU activation. So here machine learns about this image, and then we apply this soft max layer. So basically it provides probability for each possible output class, and then finally we apply the classification. And basically classification, a machine learning model used for distinguish among two or more output categories. So we can further identify, or system can further identify whether it's a horse image, dog image or cat image. Now we are going to understand one by one each process. Now let me break this each procedure into a smaller chunks, and that will be much more easy for you to understand it. So we have this image, horse image. It is a 6 by 6 image which are having these pixel values. It is 6 by 6 image. Okay. Now in the next step, since we need to convert it into the convoluted image, and that's why we are applying here the con 2D layer. Okay. So for a conversion of normal image into the convoluted image, we need to apply the kernel. Now here I am applying the kernel 3 by 3. It is also called as a filter. These values can be tuned according to your need. It could be 5 by 5 also, but here I am taking 3 by 3 kernel filters. Okay, so let's say these are the pixel values of this input image. Now we take this particular pixel values. Okay, so now here we need to apply the kernel. So first of all we need to mark it into the center, and if we apply this 3 by 3 kernel here, okay, 1 2 3 3 by 3, okay, and these numbers is, this number is in center. Okay, so how it will be calculated? We need to, since we are applying 3 by 3 pixels here, so we need to multiply this 30 into 1, 25 into 2 and 5 into 1. The same thing I did for 56 into 5, 31 into 1 and 10 into 4. In the same way these. Okay, so now we have these values here. Okay, these values you can see that. After that we need to add these values. We need to get the sum of these entire output. Okay, so that is the sum of 532. Now in convoluted image, at this place this value will come. Okay, in the same way you need to make a center of this particular, let's say you want to calculate this one 10. Okay, so you need to apply filter how, like this, like this. Okay, so in the same way you will find all these values. So finally at the moment you will have the values of convoluted image. Okay, these are the values I just filled up randomly, but if you calculate it you can exactly put the values here, and the calculation behind is the same which I did it here. Okay, so I hope now you understand that how we can apply the convoluted image, how we can get the convoluted image by applying this kernel 3 by 3. Okay, now let's move to the next procedure, which is max pooling. All right guys, so now we see that the next layer is max pool. Okay, so now we see that how we can apply the max pool. So basically pooling is the process where we are reducing the size of original image. Okay, now there are two kind of pooling. One is average pooling and second one is max pooling. but max pooling is quite famous, and that's the reason that we are taking here the max pooling, and we will see that. So here the max pooling we are applied 2 by 2, and there is a stride 2 also. So that I'm going to explain what is a stride 2. Okay, so we since we are here applying 2 by 2 max pooling. Okay, so now let's take example of this one. Okay, 2 by 2, 1 2 and 1 2. Okay, 2 by 2 we are applying here this max pool filter. So in max pool we need to always select the maximum value of this pool. So this is one pool, and in this four pool, in this single pool, these four values, the highest value is 961. Okay, so we need to mention here 961. Okay, the new image will come 961. After that we need to then further we need to move it, since we are taking the stride 2. So a stride is basically a shifting your filter from two levels, right, from this side, right hand side. So now the next pool is this one. Okay, next pool is this one. So here the highest value is 1012. In the same way, under this pool the highest value is 851. Sorry, so we need to mention here the 851, because under this pool the highest value not 68, this is wrong, so you calculate is 851. Okay, after that in the same way the next will come these pool, and here the highest value is 955, here the highest value is 954, and here the highest value under this pool is 1011. Now in the same way here is 876, in these pool here the 877, and in these pool the highest value is 966. So now after applying the max pool you will have the image something like this. Okay, so basically a max pooling is a process where we are reducing the size of the image, and it is also called a down sampling. All right, so now I understand that you easily understand the max pooling, and it's going quite easy, right? So now let me scratch your mind a bit. Okay, what will happen if I tell you, can you calculate the value of this one, this corner value, or this 15, or this 45, or 19, or this 30? Okay, how will you do that? You cannot apply here the 3 by 3 kernel filter here. Okay, because if you apply it, how you will make it into the center? Okay, if this one especially you can make it into the center, that is okay, but especially for the this corner values, corner pixel values, how you can apply it. Right now guys, here padding comes into the picture. Okay, now you ask me what is the padding. So basically, if you follow me on LinkedIn, few days back I already posted about the main parameters is required to learn for any machine learning beginners. Okay, here I have already explained what is padding. So if you see padding, adding zeros or values to the edges of an input array to maintain a spatial dimension after processing. Okay, so padding ensure images are a standard size for processing without losing details. Okay, so that's why we are applying here the zeros. Okay, so once we apply the padding, once we apply the zero, that is also known by the padding. Okay, then we make it into the center. So never mind, there is some alignment, there is some misalignment here, so never mind it. Okay, so but once we add here the once we apply here the padding, now it will be easy to apply this 3 by 3 kernel filters. Okay, so now if we apply this 3 by 3 filter here, right, on these three, 1 2 and 3. Okay, now the same procedure will repeat it, like we need to calculate this 0 to 1, this 0 to 2, and 0 to 1. In the same way, 0 to 5, 1 to 1, and then 16 to 4, 0 to 1, 4 to 2, and 30 to 1. Okay, so after that, in the same way, we need to calculate like this, and then finally we will have the sum values which will be equal to 103. Okay, so guys, these are not the manual procedures. Okay, we don't need to calculate through any calculator or through notebook. Okay, we don't need to do manually calculation. All this is automatically happen by the machine algorithm which we applied as a layer. Okay, so that machines calculated. I am just explaining you here that what exactly happens, how this kernel filter works, and what exactly what the calculations behind it, how it is calculated. Okay, so for edges values, for the corner values, we apply the paddings. Now you also understand what is the role of padding here. Okay, so finally we have, after all the cases, we will have this finally new image. Okay, now we are going to understand this flatten layer. Now I discuss about this flatten layer. So basically flatten layer is used to convert 2D image into the vector image. If you are new with the machine learning, if you don't know about how the vector image is made, I would suggest go and read about the embeddings. Okay, once you learn about the embeddings, read about what is the vector DB, how it stores the data, and there you will have the complete picture exactly what happens. But meanwhile time, since this is the different topic, maybe I will cover it later on. So meanwhile time, you just remember it like converting 2D image into the vector, the flatten layer is applied. Okay, now after that there is a ReLU activations come into the picture. Okay, so when we compile the model, a particular framework, let's say we are working with the TensorFlow. Now in TensorFlow, there is a Keras API, right? So through that, we apply different layers. Those are also called the dense layers. There we there we apply the ReLU activation. So basically, okay, if I say in general term how the machine learning works, okay, so in machine learnings, you have the input, you also have the output. Now it depends on the system. So during the training, system keeps calculating through the different variables. Those are the hidden layers, right? And then finally it reaches and it identify exact the input, and which exactly same predict the output. Okay, and then it says that hey, now this model is having the accuracy of 100%. Okay, so in machine learning models, there is a input, there is a output, and what the system exactly calculates the different variables in multiple layers, okay, to exactly identify this input image. Okay, so there we activate this ReLU activation. So actually if you go here, right, in my post, there also I have mentioned. So theoretically, you see that a common activation function in neural network introducing non-linearity. Okay, now I would say again, I would suggest here you just go and think about what is the linearity, what is the non-linearity. I just give you one example. Say dog barks. Okay, if dog barks, then there is a simple relations, right? Dog barks. And if I say that I was get fear because dog barks, right? Now this is non-linearity, something like that. Okay, so some examples you go and read about the linearity and non-linearity, and then you will have the actual. I would suggest don't just read about the theory, better you get the example of the theory where it is exactly applied, how it is works in. Now let's understand softmax layer. Okay, so in softmax layer, let's say we have some output. Okay, machine gives us some output, but what is the probability basically that can, based on that, the machines, the systems can say that, the model can say that hey, this is the horse image. Okay, so basically the soft max layer provides probabilities for each possible output class. Okay, now we have the probability. Okay, this is most probably the horse. Okay, now let's say there is a different input, right? Dog or tiger or any other animals or any other objects, right? Then we do the classification, that is another layer applied, that basically that classified between the objects, between the outputs. Okay, whether it's a horse, dog, cat or tiger. Okay, so this is how the softmax layer and classification works. So this is the entire procedure of convolutional neural network, and this is how it works. And now I understand, guys. I mean, I try to make it more simple as I could do it. Okay, so now I think that you easily understand it. And if you have any questions, you can write me. You can write your questions into the comment sections, or you can directly reach me on LinkedIn. Also, you can directly message me. I will help you there. It will be much more faster. This is my LinkedIn account. If you haven't yet follow, then follow it. So I think I pretty much explained it. So that's all from this session, guys. And if you have any questions, don't forget to message me on the LinkedIn. And one more request, guys, if you really think that it adds value in your qualifications, in your knowledge, then don't forget to subscribe my channel and share it within your LinkedIn network and with your friend. Thank you so much for watching this. I will see you in my next tutorial that will be again from the machine learning. Thank you so much, guys.